Welcome back, everybody. In this next chapter of our course, we're going to talk about some basic concepts in statistics because we want to get to the point where we understand basic terminology so that we can start discussing the nitty-gritty details that underlie complex statistical procedures. What we're going to do in this particular video is talk about different scales of measurement. I'll show you what I'm talking about in just a minute. As we start talking about measurement in a little bit more detail, let's just remind ourselves that all things scientific, all things research-based, are based on observing things and measuring things. And statistical procedures fit in because they just involve calculations that are based on those measurements. Those measurements comprise the data that we have. And remember, data is just information. So overall, measurement just involves assigning values, and those are usually numbers, to objects. Let me give you a couple quick examples. If I were to measure your age, I'd be assigning a number, maybe you're 22 years old, to you. If I was measuring your IQ, again, I'd be assigning a number, maybe 120, to you. So I'm assigning a value to an object. If I asked you how many years of education you have, and let's say you're a sophomore in college, you'd have 14 years of education. Again, I'm assigning a value, in this case a number, to you. But when we measure things, the values that we assign to some object don't always have to be numbers. Think about something like race. If we were measuring the race of a person, we'd ask that person, because we usually let people define who they are, how they would categorize themselves. Are they African American? Are they Caucasian? Are they Hispanic? Whatever it might be, but you can see there are no numbers involved there. Now that we've reminded ourselves of some basic measurement issues, let's take this discussion a step further. When we collect data, remember we're typically talking about measuring some variable, and that's because the things we're measuring vary in their values. Not everybody is a man. There are men, there are women, there are people who see themselves between categories. In other words, gender is a variable. When we measure variables, we can measure them on 4 different measurement scales. Let's talk about those scales. We're going to want to talk about these scales in order: nominal, ordinal, interval, and ratio. And one way to remember them in order is just to think about NOIR. And I'm not sure how helpful this is, but I took French as a younger student, and that is a French word, noir, meaning black. Again, I'm not sure if that's going to actually help you. But the reason why we want to remember those scales in order is because you're going to see that everything that comprises a nominal scale is included in an ordinal scale, but an ordinal scale includes something else. It's a little bit more sophisticated, a little bit more complex. And all the information included in a nominal or ordinal scale is included in an interval level scale, plus then something new. It becomes even more complex. And in general, all the properties of these 3 scales are included in a ratio level scale plus something else. It becomes even more sophisticated, a little bit more complex. And in general, we like data that is complex, that is sophisticated, because we can do more with it. So in order for us to determine what we can do with our data, we need to understand how it was measured. So let's talk about them in order. We'll go through each one, I'll give a quick example or two, and then I'll quiz you a little bit. A nominal scale really just provides us with names of categories. In fact, nominal in this case just really means name. Nominal scale data is non-quantitative, so there are no numbers with any numerical meaning. So we're just talking about category names. Let me give you a couple quick examples. Think about gender. We've mentioned this before. Male, female, transgender. You see, these are just names of categories. They don't represent any quantities. I can't put them in any meaningful order. It's not like male is bigger, more important, larger, small. No, it's just there's the category of male, the category of female, and other categories that we can include. Consider if I were to ask you a question, like, are you a full-time student? You're going to respond yes or no. Again, that data that I just measured is nominal because your response, the data that I collect, is just the name of a category, yes or no. There's nothing quantitative, nothing numerical about the words, the categories, yes or no. It's not like one is bigger or smaller than the other. Yes and no don't hold those properties. They're just category names. Here's another example. Let's say I were to ask you, if you were in the market to buy a new cell phone today, what type of cell phone would you buy? And you might say, like, I'd buy an iPhone or I'd buy a Samsung. Whatever your answer is, it's just a name of a category. There's nothing numerical about it, nothing quantitative. And I can't order those categories in any meaningful way from like biggest to smallest. I've got words like iPhone, Samsung. There's no way to put those in a meaningful order. So ultimately, in all of those examples, the scale of measurement that was used is a nominal scale. All right, let's go ahead now and bump it up a notch. Now we're going to collect data that's a little bit more sophisticated. The way it's more sophisticated is because now we have category names, but we can rank them. We can put them in some type of meaningful order. And obviously, just by looking at the name ordinal level scale, you can see we're talking about ordered data. So here we're talking about ranked categories. Let's talk about a few examples. One would be your class rank. So you, according to our university, are categorized as a freshman, a sophomore, a junior, or a senior. Those are just names, right? Names of categories. There's nothing quantitative about them. However, you can see where I can put them in a meaningful order. Freshmen have made the least progress toward graduation. Then we have sophomores. Then we have juniors. Then we have seniors. That's a meaningful ranked order. That's ordinal scale data. Imagine if I'm collecting some data about your food choices, because, we have a lot of healthy and unhealthy people in our country, and I might be interested in determining what distinguishes between those two types of people. And one question that I'm going to ask you is, when you go to a restaurant, what size drink do you order? So when you order your drink, do you typically order a small, a medium, or a large? Do you see again here how those are just names of categories? But I can put those categories in a meaningful order. I can rank them from smallest to largest. So in those examples, we have ordinal scale data. You can see in these two cases, we're talking about categorical data. This is data where we're just dealing with category names. These last two categories, you're going to see we're dealing with measurement data. So let's move on to interval level data. Interval level data should have the same properties as nominal and ordinal level data, except we add something more. We make it more sophisticated. As the name implies, when we have interval level data, we have equal intervals between each category value. Let's just take a step back for a second. Remember those drinks, small, medium, and large? We can't necessarily be assured that we have equal intervals between each one of those categories. Is the difference between a small and a medium the same amount of difference as there is between a medium and a large? Based on the measurement scale that we used, small, medium, and large, we can't be guaranteed that that is true, that we have equal intervals. When we do have equal intervals, we have an interval level scale. Let me give you a quick example. Think about something like calendar years. We're in 2020 right now. So let's just start at the beginning and try to determine what type of measurement scale we're using. So do we have at least a nominal scale? Remember, nominal scale just includes names of categories. So calendar years like 2019, 2020, 2021, those are names of categories. So of course we have at least a nominal level scale. Can we put those calendar years in some meaningful order? Of course, from like smallest to largest, furthest back in time to the future. So again, 2019, 2020, 2021, that's clearly a ranked, meaningful order. So we have at least an ordinal level scale. And this is the game you play. This is how you determine what type of measurement scale you're using. Then we're going to ask ourselves another critical question. Do we have equal intervals between each of those categories? So is the amount of time that passes from one year to the next the same each year? And unless we overthink this, the answer is yes, it is. So the amount of time that passes from 2019 to 2020 is 1 year. The amount of time that passes from 2020 to 2021 is 1 year. The amount of time that passes from 2021 to 2022 is 1 year. So all along that number line, we have equal intervals. Thus, we have an interval level scale. There is this other little detail that is important, and that is there is no true 0 point. In this conversation, I refer to that as a true 0 point or maybe an absolute 0 point. What 0 would represent, if it's a true 0 point, is the absence of what we're measuring. So think about the calendar year 0. That was a long time ago, I know, but nobody, doesn't matter what your religion is, doesn't matter what your philosophy is, nobody seems to think that was the beginning of time. Is that when time first began? No, there were years before 0. We often refer to those as BC. So do you see how when we're talking about calendar years like 2020, we don't have a true 0 point in that situation? We have equal intervals, but no true 0 point. So we are talking about an interval level scale. Let me give you another example that might be easier for you to wrap your head around. Think about when we measure heat, like in degrees Fahrenheit or degrees Celsius. Either example would work here. Again, let's start from the beginning. Do we have at least names of categories? Yes. 1 degree, 2 degrees, 3 degrees, 4 degrees. Those are names of categories. Can we order them in a meaningful way from like smallest to biggest? Yes, we can. 1, 2, 3, 4 degrees. That's a meaningful order. We can rank those categories. So we have at least an ordinal level scale. All right, when we're talking about something like Celsius degrees, let's figure out if we have an interval level scale. Do we have equal intervals all along that measurement line, that number line? So is the difference from 1 degree to 2 degrees the same amount of change in temperature and heat as there is from 2 degrees to 3 degrees? Is that the same amount of difference as there is from 3 degrees to 4 degrees? Yes, it is. All along that number line, all along those temperatures, when we move 1 degree up, we are increasing heat by the same amount of value. Let's ask ourselves, though, this critical question now. Do we have a true or absolute 0 point? When we're talking about measuring temperature, we're talking about measuring heat. So 0 degrees Celsius, does that represent the absence of heat? And the answer is no, because negative values make sense. I mean, you could measure something and find that it's negative 10 degrees Celsius. That means 0 was not the beginning of the scale. Same thing works with Fahrenheit degrees. 0 degrees Fahrenheit is not the beginning of that measurement scale. It could be negative 10 degrees outside on any given day. So in both those examples, we don't have a true or absolute 0 point. 0 on those scales does not represent the absence of what we're measuring, heat. So that brings us to a ratio level scale. A ratio level scale has all the properties of the scales before it plus something new. And what's that new thing? When we're measuring something on a ratio level scale, we do indeed have an absolute or true 0 point, representing the absence of what we're measuring. And as such, we're able to make ratio level comparisons. And that becomes very important because we like to do that a lot. Let me give you an example. So let's say we're measuring someone's age. So you might be 22 years old. If you're 22 years old, when we're looking at that number 22, does that represent the name of a category? Yes, ages represent names of categories. If someone's 22 years old, 23 years old, 24 years old, those are names of categories. Can we rank those categories in a meaningful way from smallest to largest, from youngest to oldest? Yeah, of course we can. Do we have equal intervals? Yes, we do. The difference from being 20 to 21 is the same amount of difference as there is from being 21 to 22. And then we've got the key question, when we're measuring age, which is representing how long you've been alive on this earth, does 0 represent a true 0 point? Is it essentially the beginning of the scale? And in this case, the answer is yes. Do you see how in this situation we actually can make ratio types of comparisons? So if someone is 20 years old, they have been alive twice as long as someone who is 10 years old. Even a relatively simple analysis like we just talked about right there can only be done when we have a ratio level scale. So you can start to see why this discussion is important, and it's because some statistical procedures are appropriate for certain types of measurement scales only. Let me quiz you a little bit. You can play along in your mind. And I'm going to show you how I would reason through this. I'm going to try to figure out for each of these examples if I'm dealing with a nominal, ordinal, interval, or ratio measurement scale. Think about something like political affiliation. So that's data, right? I'm collecting information about people. And if I'm collecting data about their political affiliation, I want to know in general, are they a Democrat? Do they see themselves as a Republican, an independent, or some other party? So I'm always going to start at the simplest level scale. Do I have at least a nominal level scale? Everything is at least a nominal level scale because I've got names of categories. So the data that I've collected, words, names of categories, Democrat, Republican, Independent. So yes, I at least have a nominal level scale. Let me see if I can fit that data into an ordinal level scale. Can I take those categories and put them in some meaningful order from like biggest to smallest, most to least? And the answer is no. There's nothing about the category Democrat that makes it big or small. There's nothing about the category Republican that makes it big or small. There's no way to put them in a meaningful order. There's no way to rank them meaningfully. So ultimately, when we're talking about political affiliation, we're dealing with the nominal scale. Let's go through another example. Let's say I'm trying to figure out how far you all have to drive to get to campus because, we're trying to figure out what's our service area. At some point, people are going to say, your campus is too far away. I can't drive out there. So think about the data I'm going to collect. One person might respond, I drive 10 miles to get to campus. Another person might respond, I drive 5 miles to get to campus. Someone else might drive 45 miles. So I've got some numbers. So do I have at least a nominal level scale? Do I have names of categories? Yes, 10, 20, 45 miles, those are all names of categories. Can I rank those categories in a meaningful way? Yeah, absolutely. 10 miles is more than 5 miles. 45 miles is more than 10 miles. So clearly I have at least an ordinal level scale. Do I have equal intervals? So when I'm measuring something like miles and I'm looking at that number line, is the amount of distance equal all across that number line? Is the distance from 1 mile to 2 miles the same amount of distance as there is from 2 miles to 3 miles and 3 miles to 4 miles? And the answer is yes. Then there's that critical question to determine if I have a ratio level scale. Do I have a true or absolute 0 point? Is 0 miles like where that scale actually begins? Does traveling 0 miles mean you have not traveled anywhere at all? Is it the absence of traveling miles? And the answer is yes. If you've traveled 0 miles, you have traveled no miles. So we do, when we're measuring mileage, have a ratio level scale. So if you drive 50 miles to go to campus and I drive 25 miles to go to campus, you do drive twice as far. That's a ratio level comparison. Let's just go through one more real quickly. Let's say that at work, I'm giving people performance evaluations, and they can be evaluated as superior, above average, average, below average, or poor in the work that they're doing. Let's start with a nominal level scale. Do we have names of categories? Yes, obviously we have names of categories. Can we put them in some type of meaningful order from like biggest to smallest, most to least, or in this case, best to worst? Yeah, we could do that. Like superior, above average, average, below average, poor. Even the way that I listed them to you, they are in a meaningful order. So we have at least an ordinal level scale. Do we possibly have an interval level scale? In order to have an interval level scale, we need to have equal intervals, equal distances from one category to another. So when we're talking about the performance of an employee, is the difference between a superior employee and an above average employee the same amount of difference as there is between an above average employee and an average employee? Is that difference the same amount of difference as there is between an average employee and a below average employee? I think you're starting to see we can't be guaranteed of that. So in this situation, we do not necessarily have equal intervals. So when I'm talking about these performance rankings of employees, ultimately, I only have an ordinal level scale. So let's wrap this up. Again, I mentioned that this is an important discussion because we need to understand what type of data we have and how it was measured so that we can determine the most appropriate statistical analysis to perform. Over the years, I've seen some people do some really crazy things with data. For example, in a data set, people might decide to use numbers instead of names when entering their data, and that's fine. That's a common thing. So if someone is a male, they might put a 1 in their data set. If someone is a female, they might put a 2 in their data set. But is there really something quantitative about that data? If you think about it, what we have here is just data for a person's gender, and that's just nominal level scale. We said that's categorical data. That's not even measurement data. But I've seen some people compute means, averages of that data. That makes no sense. They don't understand the type of data they're dealing with. Here's another example. When we're dealing with a person's IQ, here we're talking about intelligence scores. Ultimately, we're just dealing with interval level data at best. A number of 0, an IQ of 0 is is really just not a value that makes a lot of sense on an IQ scale. But someone might look at Joe's IQ, which is 130, and Bob's IQ, which is 100, and think that Joe is 30% brighter than Bob. The number 130 is 30% higher than 100, but we can't use that type of ratio level comparison when IQs don't represent ratio level data. But remember, we learned about the difference between a Kelvin scale and a Celsius scale or Fahrenheit scale, and we learned that that is ratio level data. So using those same numbers as we have above, is 130 Kelvin 30% warmer than 100 Kelvin? Yes, it is, because we're dealing with ratio level data. Bottom line is, we need to understand how we measure the data so that we know the most appropriate way to analyze the data. Well, that's enough for right now. I hope you found this interesting. In our next discussion, we'll talk about distinguishing between different types of variables. In the meantime, be safe.